Continuing right along, I'd like to take a few moments right now to address a minor problem that does come up when you're doing a lot of asynchronous programming in JavaScript, and therefore, frequently here in Node, and that is a problem with the this pointer. We'll find that we have a little bit of quirkiness with that. So let's take a look at how that will affect us. What I'm going to do now is I'm going to create a new file called fob.js, and I'm going to create a little file object that'll do some simple file operations. So first, we're going to always use the fs module, and then I'm going to create a file object class here, which will have a property called a file name, and I'm going to give it a function called exists, and that will be a function that will take a callback for asynchronous use, and I'm going to add some methods to it now. So what I'm going to do to see if a file exists is I'm going to try to open it. And so I'm going to say open this.file name. I'm going to open it for reading, and then I'm going to take the data like that. Now, I'm going to break the callback signature, the sort of pattern we talked about in the previous part. Normally, we said that we would have an error and then some valid data. For the callback that our exist function is going to call, I actually don't ever care if there's an error. If there's an error, that just means it doesn't exist. Otherwise, if there's no error and the file exists, then we'll return true. Otherwise, we'll return false. So I'm going to say if there is an error, I'm going to add a little bit of debugging information here. Console.log this.file name does not exist. And then I'm going to say callback false, doesn't exist. If there is no error, I'm going to say console.log this.file name does indeed exist, like that. And then I'm going to call back true. And then if it did open, I'm also going to just be polite and close it down, although that's not super necessary because when I exit the program, it'll call. But anyway, that's my class. Then I'm going to say var fo equals new file object. I'm going to give it a file name that does not exist for sure. And then I'm going to say, does this file exist? And does it exist? I'm going to give it a callback function. And again, I don't care about errors. I just want to know, does it exist or not? And then I'll say console.log results from exists, like that. Okay? So, assuming I typed all this in correctly, let's node f_obj. You'll see the results from exists false. It does not exist. Now, you'll see an interesting thing has come up here. It says undefined does not exist in my debugging code. And I said this.file name does indeed exist or does not exist. So for some reason, it now thinks that this.file name is not valid, despite the fact that I have that here. And indeed, it's even stranger, because if I do console.log attempting to verify plus this.file name, if I run it like that, you'll see it actually does know what this.file name is, but suddenly from here down to here, it forgets what this.file name is. It loses it. And again, this is a sort of quirk or an oddity of asynchronous programming. When I am executing this exists function, I am executing within the context of this file object class or this file object function. So that this pointer refers to this file object, and so whenever I ask for this.file name, it knows to go and ask for this one. The problem is, by the time I'm executing this callback function here from the fs.open function, I am executing it in a sort of different this context. My this pointer is no longer valid and doesn't refer to this file object anymore. So when I ask for this.file name here, it now no longer knows what it is. Now, that seems like kind of a fatal sort of flaw that we need to be able to get around. And the good news is that we can. Even though this function does not have the same this context as functions executing in the context of the file object, it does have the call stack or sort of local scope of the functions that called it in sort of the stack it's executing in. So what I can do here is I can declare a variable called self and assign this pointer to that self. So this function, when it executes, even though it's this pointer is not the same as this function's this pointer, it does have access to these sort of local variables and the scope that this function created. So what I can do now is I can actually just replace instances of this with self. Some people don't like self, they think it's too long, or so they use me or something like that. I've just taken to using self, but you can call it whatever you want. You can call it elephant if you want. It just needs to be a variable because then you have something in your scope that you can refer to within your callback functions here. Now, with that as the case, I can run it and you'll see indeed I know what my, I've sort of managed to fake Node into giving me my this pointer back by putting it here in a local variable. So it's not a fatal flaw, and it's something we just you'll end up using in all of your scripts all the time. Like whenever I write objects in Node.js, even if I'm not calling asynchronous functions, I just do the var self, and I always refer to the self from there on out to sort of avoid bugs. It's a very common pattern, and you'll see it in pretty much any Node code you look at and you browse your way through. So that is to solve this sort of this pointer problem in JavaScript, and that's kind of probably only the real major quirk we're going to run into that we have to constantly work around. So with that in mind, let's go ahead and look at some other optimizations or things that asynchronous programming will introduce.